Good morning. Myself, Professor Sangeeta Gupta from CBIT Hyderabad. Today we will be discussing about the computer organization and architecture, which is a topic to be discussed with important for all the competitive exams where we have different fixed point operations and also floating point operations. So before we go with the different operations, first it is necessary to understand the important operations under computer arithmetic. Okay, so these operations are, we have addition, then we have subtraction, and we have multiplication and division. So these are the basic operations on which we can perform different arithmetic operations in the computer. However, to represent all these operations, we have two notations. So these notations are fixed point representation. The first one is fixed point representation, and the second notation is floating point representation. So under fixed point representation, both are used to represent integer values and fractional parts, but under fixed point representation, whenever we are trying to represent a fractional part, in that case, the decimal value will remain fixed. We cannot move the decimal for that examples. For example, if I take 12.34, 24.45. So here we have two digits after decimal. So whatever is the number of digits after decimal, we have to fix it. Whereas in floating point, here after the decimal we can have variable number of digits. Like if I take 12.345, where there are 3 digits after the decimal, 45.67, 67.4, etc. So these are the differences in between fixed point notation and floating point notation. Now, whenever we represent a positive number, so this positive number is represented only as an unsigned number. Any positive number is represented as an unsigned number. But when we have to represent negative numbers, then there are three ways to represent the negative numbers. Okay, the first one is using signed magnitude representation. Signed magnitude representation. This is one way to represent the negative numbers. And the second one is using signed ones complement representation. And then the third notation is using signed twos complement representation. So these are the three ways in which we can represent a negative number. Now, how do you represent the numbers? Basically, in all these three formats. For example, if at all you have a number which is plus 45. Plus 45 in decimal, you need to know how to represent that in binary. So I'll just show you an example. 45 by performing repeated divisions by 2. If you just try to perform repeated division by 2, then 2 dividing 45 by 2 twos are 4 and 2 twos are 4. So remainder here is 1. Now once again repeatedly divide by 2, you have 2 11s are, no remainder here, remainder is 0. Then 2 5s are 10 and remainder is 1. Then you have 2 2s are 4 and remainder is 1. Then you have 2 1s are 2 and remainder is 0. So the equivalent here is 1 0 1 1 0 1. This is the binary equivalent for the decimal number 45. So we have taken the values in this way, that is from bottom to top, 1 0 1 1 0 1. This is the result. Now, if generally whenever we are representing data inside a computer, the processor size, it will be taken in terms of powers of 2 or the smallest one, 8-bit, 16-bit, 32-bit, so on. So if we want to represent the data as 8-bit, we can add any number of zeros to the most significant bit positions. So here we have 6 zeros and I'm adding 2 more. This does not make any difference in the result. Now, when you want to represent the same thing using signed magnitude representation, that is plus 45 will be represented in the same way. If you want to represent minus 45, okay, let me just write it here itself. If it is minus 45 and you want to represent that in all the three formats, then first thing is we need to have the binary equivalent of plus 45. So binary equivalent of plus 45, we have got it here as 00101101. In signed magnitude format, the remaining bits, only the MSB bit is taken as a sign bit and the remaining bits are taken as a magnitude bit. So only the MSB bit, that is a sign bit, will be inverted to 1, indicating that it is a negative number. Remaining bits which represent the magnitude here, that is 0, 1, 0, 1, 1, 0, 1. All these bits will remain same. So we can see here all the bits here are divided into two parts. The MSB bit is taken as a sign bit and all the remaining bits are taken as magnitude bits. So in sign magnitude representation, the magnitude part for a negative number remains same and only we are inverting the sign bit. Okay. Now in the another representation where we are trying to show the negative ones complement representation, we have to invert the bits, all the bits of plus 45 in order to get the result under minus 45. So inverting the bits in the sense zeros becomes 1 and 1s become 0. So we have 1, 1, 0, 1, 0, 0, 1, 0. 0 has become 1, 0 has become 1, 1 has become 0, 0 has become 1, 1, 1 has become 0, 0 and 0 has become 1, 1 has become 0. So this is the equivalent in signed 1's complement representation. Similarly, signed 2's complement is you have to add 1 to 1's complement. It will give you the 2's complement representation. Okay. So these are the different ways in which we can represent the negative numbers. So thank you for watching. Hope you have liked my video. Please, I request you to subscribe to my channel and share my video popularly. Thank you so much.